Okay, hello. Thank you for coming. I will give a short introduction to the lecturer today, Iro Mathioudaki. She holds a BA and a PhD in prehistoric archaeology from the University of Athens. She's a field archaeologist and pottery specialist, and from 2021 to 2022, she taught the course of Minoan and Mycenaean archaeology as a lecturer at the University of Patras, and currently she teaches at the college year in Athens. From 2017 until 2020, she completed a postdoctoral research at the University of Louvain, and since then, she has been associate researcher of the GIS research group. Iro Mathioudaki has studied material from several sites in mainland Greece, Crete, and the Cyclades, such as Knossos, Iouchthas, Mallia, Sisi, Akrotiri Thera, Agios Vasilios, Kira, and she has received grants and fellowships for research projects from the Institute of Aegean Studies, the Knossos Research Fund, and the Knossos Donated Fund of the British School, the National Fund for Scientific Research of Belgium, the Mediterranean Archaeological Trust, and the Shelby White and Leon Levy Program for Archaeological Publications of Harvard University. She has completed a personal research project entitled The Pottery from the Houses of the Fallen Blocks and the Sacrificed Oxen at Knossos, and has ongoing research projects relating to the palaces at Mallia and Knossos in collaboration with Dr. Maud de Volder, today in the audience, and Dr. Luca Girella, Professor Maud de Volder, I'm sorry. She has co-authored a book with Carl Knappett and Colin MacDonald entitled Knossos, From First to Second Palace, an integrated ceramic stratigraphic and architectural study. And today she will give a talk about ceramics. And the floor is yours. We're looking for.
Thank you. Thank you, Tina, for the introduction. Can you hear me? Ναι. So, good evening. I would like to thank the Belgian School at Athens and Tina and Will for inviting me to give this talk in their very successful Atlas seminar series. So, how do we map ceramics? What do we mean by that? It is more than just putting production centers on a map. Today's talk is mainly about computational statistics and data analysis, and what can we do further with the pottery that we study as pottery specialists. I will not talk about a specific site. This talk is based on my expertise as a pottery specialist and the difficulties I have encountered in quantifying ceramics. I would like to share with you methods, views, and even find a basis for a future collaboration, especially as far as computational methods are concerned. Firstly, the quantification methods we use, a few words on this, can be divided into two groups. Those which give an approximate estimate of the quantity of pottery when we count sherds, for example, and those which are designed to calculate the number of vessels, the original number of vessels that was in an assemblage that was included. Archaeological quantification is a recurring theme, and much has been written about it. All methods of quantification are valid and are accepted as long as they are properly cited. So, sherd counts, mini eyes, which are the minimum number of individuals, in our case of pottery, the IVEs, the estimated vessel equivalents, or sherd weights. The IVEs involve measuring the arcs of the rims and bases in degrees on a rim chart, as shown in the picture. One of the advantages of this method is that it solves the problem of varying degrees of breakage in pottery types, because the way that pots break depend on the type also sometimes. Different types break differently. So this takes it into consideration, especially in very fragmentary assemblages, but it is a slow method, that is the problem. So calculating the volume of ceramic vessels is also an important analytical tool that can have implications for social activity. In the case of Minoan periods, for example, the communal gatherings, or when one studies the cooking pottery, it's also very important, the calculation of the volume for food etiquettes and preparation and practices. Volume estimation methods are based on the assumption that vessel shapes are approximately circular or elliptical form in plan view. See, for example, here, from the work of Todd Whitelaw for the pottery of early Minoan Myrtos, Furnu Κορυφή, where this method is used with some adjustments. Working with volumes and metrical variables, one also explores behavioral parameters, emphasizing typological replication. What we mean with typological replication, for example, when you have types that in aspects of volume, they contain the same volume, but they are different. You have a lot of different cups, for example, which contain the same volume. So then we wonder why. This is a typological replication, let's say. And wear overlap, where you have wear overlap. With wear overlap, we mean when we have a cup, for example, a straight-sided cup, that is encounter plane, and is encounter monochrome also. Is encounter the same type, dark on light on dark. This is a wear overlap, and this is also interesting, and it's interesting in this case also because it means something for the volume that the vessel contained, as a way to investigate an established etiquette and the underlying behavior. Is also important aspects of pottery studies. Now to the computational analysis of the data. So, quantitative data can be presented using frequency illustrations. When we use, for example, tables, and we say how many pots we have, and graphs, as I do usually in publications. I prefer the axis that you see here. This is the program that I use when I enter data, the Access database, and then I extract. This is an example from Akrotiri Thera, and then I extract the data and what I find as important from this database, and then I form the charts and the graphics that goes with it. That goes with it. But the thing is that I always take what I think is of importance, not everything, because not everything should be presented on a graph. Only the things that the archaeologist considers important for this specific assemblage. Also, the counts should be better converted to percentages to make deposits of different sizes directly comparable. When you have percentages, your deposits are comparable, unless there is the case where you want to prove something on the exact number of the certs and of the pots. If you want to show, for example, that an assemblage is really big. So in this case, you need to give the precise numbers. This is another example published in the Knossos from first to second palace. Usually when I present tables like that, I try to compartmentalize, to segment the information to different levels, and so that the table can be read from different angles. Not only shapes, but also wares are included, and what is important in order to see with one look what it contains, what the assemblage contains. To be very informative, as much informative as possible. And another one here from Sisi, which is the building CD. Here I tried to show also stratigraphical information. So in order to gain a full understanding of relative dating, including internal relative dating, when, for example, we are excavating deposits belonging to the same horizon, and we want to see what is the relationship between the deposit, a consistent method needs to be applied. And the appropriate methods for this are the seriation and the correspondence analysis. So, Sheriff-Linders-Petrie, based on pretty nasty Egyptian materials, is generally credited with the invention of seriation. And the idea of seriation remains an important foundation of archaeological methodology in relation to material culture. The most common method of seriation is frequency seriation, so we seriate the frequencies of each type. It uses the relative frequencies of the types in order to form a sequence among several assemblages. For the frequency seriation, we have two main assumptions, two basic assumptions. One is that the types follow a bell curve of popularity, gradually increasing, reaching a peak, and then they decline. And the second assumption is that types and styles, the peaks and the declines of types and styles will be more or less similar between sites of the same culture. This is the second assumption. So if we see a peak of the straight-sided cup, for example, or of the ball, of the in-and-out ball in Minoan sites, that means that the same peak will be present in all the sites of Minoan Crete, more or less. It will peak in the same, because they belong to the same culture. So seriation was used by Davis and Cherry in their efforts to define the relative sequence of late Cycladic I deposits at Philakopi back in 1984. They had well-stratified late Cycladic I deposits in 9 separate trenches, but the problem was that the soundings were discontinuous and the deposits could not be directly related. This is a very common problem in archaeological stratigraphies, and especially when you have a large site that has been horizontally excavated for quite a long time, this is a very common problem. So, in order to better establish the relative sequence of the late Bronze I levels at Philakopi, Davis and Cherry, they applied seriation techniques with quantified data to each unit, based on the common number of features of every unit. And this is the principle of seriation. So what we see here is just two trenches, and the battleship diagrams that you see here, the frequency seriation actually, are the 8 different types that are encountered in each trench. Now I have only the 2. They had these are counts, of course, counts of the type in different zembles, okay? They are presented as such. To do this, they chose these 8 ceramic classes that showed variability in frequency. So that was an archaeological choice. They chose to do that. 8 specific categories, such as local conical cups, local painted pottery, Minoan imports, the Cycladic cup, some types that are really important and quite repetitive. And using multidimensional scaling, which is a multivariate statistical technique close to cluster analysis, they arrived at a relative degree of similarity between the units. And here, the separation or the distance between the nodes on this map, called this map, reflects how similar they are in terms of the representation of different pottery categories. So this is the pattern that was formed from the trenches, from the different quantities of its type in every trench. And here you have, this is what they basically wanted to do. So they had some historical information, which is the building of the Great Fortification Wall, which is in the middle. And you see the pointer? Or not?
No.
Okay, taxi. You can see that. It's in the middle. And then you have the Tefra Fall, which is again another historical point. And we all have that, I believe, at some point, the Tefra Fall. So you understand where they came from, what they wanted to see. They wanted to see, based on these historical points, where the deposits, which the deposit basically are all dated in Lake Cycladic 1. Okay? So they wanted to see where they stand, taking into consideration these specific moments in the history of the site. And you had the earlier, which is the early Lake Cycladic 1 floor, and then the end, which is the later Lake Cycladic 1 floor, which is the highest. And that was very successful, actually, if you think about it. A more advanced step, since then, of course, we have more advanced steps, is frequency seriation. And here with the typical battleship diagrams, which arrange data in one or more series, which today has been reconceived as a general method for studying the structure of cultural transmission through time. Frequency seriation is a technique that produces chronological sequences by arranging descriptions of assemblages so that the frequencies of types or classes form unimodal distribution. Unimodal, with unimodal, we mean a frequency with only one peak. This is the main thing for frequency seriation. It needs to have only one peak. While a few assemblages can be seriated using hand manipulation, in some cases, when you have a few assemblages, you can do this. You can do hand manipulation, sorting all possible orderings. You can do that if you have few assemblages. But for very large sets of assemblages, it is not easy, even using modern computing power. The order that is being produced so depends greatly on sample size, on the spatial variation, and on several other parameters. For this reason, two types of seriation nowadays, we have two types of seriation. We have the original, the frequency seriation, and then we have the occurrence seriation. This is the latest one, which uses presence-absence data only for its type or for its class. In effect, it provides an optimization solution. It is good when you have large deposits because it optimizes the data. In graph theory, okay? It is similar, it gives a solution similar to the traveling salesman problem. This is a problem that asks for the shortest possible route that visits its city exactly once and returns to the original city. It's like a riddle. This is the so-called traveling salesman problem. And so, in fact, it gave a solution to this problem in statistical analysis. Frequency seriation is complementary to correspondence analysis, and it increases the analytical power of the two methods. The site where this analysis has been applied on a large scale is Troy, through the work of Donald Easton and Bernhard Benninger. Peter Pavok's 2010 article, it's a very good article that everybody who deals with quantification should read this. In 2010, it epitomizes the pitfalls and the recommendation for using the method. And this paper that you see here, the one of Benninger and Krauss, 2023, from the Chronos volume, edited by Jan Driessen and Tiziano Fantuzzi. You can also look it up because it gives a very good resume, review of all the work that has been done in Troy and Varna by Wenninger and Krauss, respectively, on seriation and correspondence. So the first attempt was made in the early 1990s by Easton and Wenninger, who initially focused only on wheres. They mainly focused on wheres, which proved to be a problem, focusing on wheres. They mainly focused on wheres because they were questioning Blagen's typology. So when you had a problem accepting specific types, they said, okay, we are going to solve this problem by focusing on wheres, because every set has a where. So we can have more data if we use wheres. The correspondence analysis work on Troy was resumed from the 2000 on by Easton and Wenninger, and this time they attempted to consider not only presence-absence data, but also counts, so frequency data, abundance data, and to include types as well as wheres. And this is the result. They had a proper analysis, correspondence analysis for the pottery of Troy. More analytically, correspondence analysis and principal component analysis, we will talk about it later, are both model-based statistical methods, which means they are exploratory methods. Correspondence analysis was first applied to archaeology in France in 1975. And what it mainly offers? It offers a visualization of multivariate data. Central European prehistory and Neolithic studies in Germany were renowned for the application of correspondence analysis in the study of pottery already in the 80s. But this was never broadly applied in Aegean archaeology, with the exception of Troy, and this because from the beginning it was supported by Manfred Korfmann. So we see, again, it's a matter of choice. Now the analysis that I did with Tiziano Fantuzzi based on the neopalacial material from Sisi. A few words first on the human factor. So an archaeological judgment of relevance must be made before the analysis begins, and it must continue throughout the analysis, and it is entirely our responsibility. It's a responsibility of the archaeologists to do that properly. Now you see, it is a cross tabulation that you see, or cross tab. You can also find this graph as biplot or plot. The N is the original number of the sets that were taken into consideration. Initially, the data were much more that I studied, the pods, the sets were much more, but these data were refined and were reduced, which was a whole process to do that. For reasons of fragmentation, mixed deposits, for several reasons. And it is the pottery, as I told you, neopalacial pottery from Sisi. And this is a typical correspondence analysis graph with positive and negative values. We have both types included here and contexts. The types, the contexts are the black letters in the middle, and the types are the blue ones. Okay? The types are much more widespread than the context. It is the light blue circle, showing that many of the types were in use earlier, they fell out of use later, or persisted through all the periods considered. So, in fact, some of the types act as outliers, and they pull the edge of the graph. A good analysis also takes into account the angles which are formed by the lines connecting 2 points. For example, you can see the red lines that I have. The angle that is formed is being analyzed, the degree of the angle. In a good analysis, one should do that also, because it is important for the connection of the points and their distance from the center, from the centroid. So everything is connected, and it is a very good parallel to see this game with the finger and the strings, and the string and the fingers. I don't know if you have played that game. It's a common game. But it is a nice parallel because everything is connected together. And if, for example, this is actually what a correspondence analysis graph is. Everything is connected together. I mean, if I pull something towards the end, everything will change. It binds it. And it's also multidimensional. It's not like in two-dimensional as that we see it here. This is what you can see with the negative and the positive values. It helps to think of it as having two sides, which is the left one, which represents the early neopalatial part, and the right side represents the late neopalatial part. You have to prove it. It's not for granted. You have to prove it, which side is the earlier, which side is the later. And sometimes the data are inconclusive. It depends on the data and the quality of the data. Actually, it's a very good test whether you have good data or not. The broad conical cap now that we see at this edge, the BCP, with the majority of examples from the MM3A context, is clearly in the upper left edge. So it pulls towards the upper left. And so does the straight-sided cap. If you see it a bit further down, is the straight-sided cap. And the S-profile cap, which is a later form, does the opposite. It's the one over here, above the table. I think I told you that the physical proximity of the points reflects a close association. I'm not sure if I told you that, because this is the main thing. Okay. So if the points are close to each other, it shows that they have a very good association with each other. So we have the S-profile cap, and then you have this I give you as examples, the specific types, to see how it works. And then we have the bridge-spouted jar, which is a shape that is common in all the periods. It is very common in all the neopalatial periods. So this is positioned close to the central axis of the graph, telling nothing, in fact, because it is everywhere. Following these lines, one can make relevant observations about the position of all points on the graph. So it is quite instructive. It is a matrix of linked elements. In our 2023 publication, we examined the abundance and both abundance data, frequency data, and presence-absence data from CC. It was like an experiment, and all data, we included all the data, as I told you, with some reduction, with some optimization, as well as tableware data, following archaeological judgment. And you have to prepare the tables by making choices, adding specific categories depending on the question. And here, in this particular table, we created because we wanted to investigate types of chronological importance and see the position on the graph. So again, specific choices were made. If you see, you have the plain pottery. There are in fact 3 columns. You have the plain pottery and the type that makes sense chronologically. And then you have the monochrome, where, let's say, and the type, monochrome types, that again makes sense chronologically. And then you have dark on light style with types. This is why you see some combination, for example, bell-shaped cap with ripple pattern, because it is important chronologically. Right on with ripple pattern. You make this combination on your own, depending on your material. This is why it's ideal. You need to study also the material. You cannot do it as an external. It's difficult. So we built on existing work on correspondence analysis, as published here by Veninger and Krauss, again from the Chronos volume. And this is all the work. It's a very nice table for the work that has been done on correspondence analysis in the Aegean. Of course, Troy is the most abundant material and the most the one that is very intense in the presence. And the most important is what you see, Troya 1, 5, Schliemann, it's number 9, because you can see from the rows and the columns and the inventory how much material has been analyze, and this is also taking into consideration types. This is what actually, because it has a broad time span, starting from the early Bronze Age until the late Bronze Age, it is one of the best analyses for the potentials of the correspondence analysis, what can it really offer. And also, Bernhard Weniger took into consideration the Fuhrmark. He was interested in looking also at published data, like the Fuhrmark, because in fact you can do that with published data also. You can create tables based on published data and run them with correspondence analysis. This is also what Tiziano Fantuzzi and Charles Sturz did for the Knossos. If you see number 3, which is again a lot of data included, but these are all published. Of course, published data have their own limitations. You take that into consideration. And they included material from Knossos MM3A until LM3B, so a lot of data, which showed also chronological variation. And how correspondence analysis work? It is based on the geometric approach. It is, in fact, an exercise in multidimensional geometry. This is why everything is interconnected. When you do correspondence analysis, you can also do cluster analysis. The visualization provided by correspondence analysis, in fact, reveal patterns, reveal clusters or trends in the data that are not visible when you look at a table. And here we have the correspondence analysis results shown with clusters as determined by hierarchical cluster analysis on the principle. So also a principle has been taken into consideration, which gives more strength in the statistical analysis. This is from prehistoric ceramics of Memphis and St. Francis area of the Mississippi River Valley. A lot of work has been done by Lippo and others on this data. And clusters are also revealed in our case here for the Sisi material, for the neopalatial deposits. So actually, the clusters showed that we had the earlier part, which is the early neopalatial pottery, which is the dark red, and then we have the late neopalatial pottery. So you have again a regression. You have this curve that is important, the so-called parabola, which is an indication of chronology. And then we have another one, like an outlier, which is the MM3A deposit. A marginal, weird deposit, also in aspects of functionality, it is also very limited. And no wonder its position is there. But of course, we needed to understand it and justify its position. This is the case of the Chalcolithic necropolis of Varna 1. Here we saw also this parabola, which is the horseshoe curve. It is very intense in the case of Varna. Another case of interesting data. The shape reflects time here. It is a chronological sequence at the end. These results have also been confirmed. What is very good for the case of Varna, which is a case study on its own, is that the results have also been confirmed by external factor, which is the radiocarbon dates. You need to have an external validation for the chronology. It's important. And this was supposed to happen also for Sisi. They have two main chronological components of the Varna cemetery. First, it is the archaeological content and the statistical properties of the correspondence analysis. And then they had the absolute age calibration. Again, in collaboration with the work of Bernhard Weniger. And Clemens Schmidt, who also is a mathematician. Using binarized data, presence-absence data, they were able to draw interesting social conclusions. For example, that differences in grave goods primarily reflect social and not chronological aspects. This is very important to be able to prove it. Correspondence analysis with radiocarbon validation even allowed, in their case, the derivation of a calendrical date for every grave in the cemetery. Very impressive, extremely impressive. And so what software do we use for the correspondence analysis? There are many statistical software tools and packages available that can perform this analysis, such as proper statistical programming languages like R, SAS, Python, and for commercial software, which I prefer the commercial software because I wanted to have a kind of control on the data, otherwise it's mathematical types, unless you collaborate very strongly with the mathematician. There is for commercial software, there is the Excel Stat, which is an Excel add-in with many advanced tools. And the program that we used for CC, the program for the creation of these graphs, is the freeware PAST4, which is the paleontological statistics software, which also has a correspondence analysis module. Easy to use, easier to use. Now some other methods which complement correspondence analysis. Principal component analysis. I would like to do that for the data that I have. The next two analyses, I would like also to perform them. Is a method, the principal component analysis is a method that belongs to the family of factor analysis. It is a mathematical procedure that transforms a number of correlated variables into a smaller number of uncorrelated variables. And these uncorrelated variables are important. They are called principal components. And in fact, they show the variability of your analysis. Variable data are the data that you can count on because you don't want all your data to be similar. You want them to be variable so they can show something. And this is what principal component does. They found the variability of your data. For example, in this case, the long line that you see, this is a principal component line because it includes your most varied data. While the shortest one has less variation. You cannot count on the data that are in the axis of the shorter line. The aim of the principal component analysis is a reduction technique. It reduces the noise and it detects the outliers. And it gives a dimensionality of the data. In fact, it tells you how to use fewer data with the most variance. So you can say something right away from your analysis. And then we have the constraint or the canonical correspondence analysis. This is a type of statistical conditioning. I'm also interested in that. This is in fact a spin-off of correspondence analysis. It is one of the latest. And it is mostly used by ecologists to allow them to relate abundance of species to environmental variables. And it's also used for demographic analysis and medical research. And it explores the relationship between a contingency table and a set of variables. It has been done for pottery by Poblom and Gronen for the material of Salagassos in Turkey. So very interesting analysis also that. By using a constraint approach, the correspondence analysis is forced to match the additional information that you give to it. It adds additional information. For example, if you know that two assemblages are of the same date, and you know that for sure, you can constrain the correspondence analysis so that the scores of these assemblages are equal. So it gives more depth to the analysis. And by incorporating time constraints in this case, and there are different types of time constraints. For example, when you know the exact dates, or when you know the order in time, this is also chronological information, or when you know that some assemblages work as termini a quo. This is also important. You know that they come before something or after something. It would be interesting because we have the point of the theta eruption. So it's interesting because we have a specific point in time. And now some reflection on the work that I have done on correspondence analysis as concluding remarks. As Peter Pavlouk says in his reflection on Troy analysis, It is useful in principle, and I agree with that, but the results are not as straightforward as one would initially hope. And they tend to confirm what is already known. But this happens because, I agree with that, but this happens because we need a mathematician who is also an archaeologist. It is quite impossible. It would be nice, but that would be the idea. That would be the idea. Although the work in Troy, years long and quite extensive, has shown its progress, for example, in Troy, when they implemented the method, they, of course, they understood that they were missing strata. That was shown by the correspondence analysis. They also understood shifts in pottery development. You get a lot of things from that. Or problematic assemblages that are bad for the analysis, that should be treated as outliers. And there is room for further work on that. And also another thing is that you cannot throw data into the analysis without considering the relevance. You need to select the more appropriate deposits and use these only. That would be the ideal thing. A third thing is that one needs to examine the methodology before and after the analysis for the effectiveness, and analyze what worked and what did not work afterwards, not just produce it and then leave it. You need to analyze, you need to understand why it didn't work or why some things worked, and try to understand. Of course, here a mathematician is needed. And it is better to have a larger database, the last one, with more assemblages to reveal subtle differences. The larger database, it's important. For my case, because we included all the neopalatial material, we had a problem because of that, because we didn't have much variation. And it kind of showed what we, or the pottery, the correct pottery was not that much, where you can count on. So you can understand, you can make your own conclusions on which data would be ideal for such an analysis. Also, the time span should ideally be longer, also include, the Middle Bronze Age, the Olive Period, Middle Minoan 2, and then Late Minoan, Late Minoan 1, Late Minoan A, Late Minoan 1A, Late Minoan 1B, Late Minoan 2, Late Minoan 3, everything. That would be more variation in the data. So I hope that through this presentation I have been able to clarify some aspects of the use of quantitative analysis for pottery studies in the Aegean. And I would like to thank you very much for your attention and for your patience.
Are there any questions, comments? Tina.
I have two questions. The first one is kind of stupid. The S-shaped cup, is it the same thing that on the eastern part of Crete we call the ogiva? Or is it a different type?
Different.
It's a different type. Okay.
The S is the one that is conical and has a straight base. And you mean the S profile cup?
Yeah, because I saw it as a chronological.
Sometimes, yes. Yeah, sometimes, yes.
Sometimes, yes.
Yeah.
So,
it depends on who does the pottery study.
Okay.
No.
Because I didn't see any ogival cups in your charts, which could be accidental. But then I noticed that the S profile is a marker for the later part of the evaluation. Or is it another 1B type of shape?
No.
Yeah.
Yeah.
Okay.
Yeah.
Okay.
It's a later shape. I have it also. I use that sometimes, but it needs to be very.
The S profile.
The ogival one.
Yeah. Okay, because in Eastern Crete we call them ogivals, and I'm trying to understand, the correlation with because you are more.
No.
Okay, that was one. And then provocative question, which I don't know if my position allows it, but I will do it. Why did you say that you didn't manage to have this C14 dating for the sissy material?
It was supposed to be a part of the project of the Arctalos. I don't know what the situation is.
but it was a
No.
problem.
In fact, the radiocarbon data should be combined with the correspondence analysis.
Yeah, but my question is, did you think that it was not possible because of the conditions of preservation
funding,
or
I guess, of funding.
The excavation? It was a problem of funding. Okay.
But it will be done.
Okay. So this is what I wanted to know, if it's possible.
It is. And actually the radiocarbon data would create a better position. If we had radiocarbon data, it would facilitate the correspondence analysis. But the radiocarbon data should be from the specific deposits that I studied.
Yeah, I understand.
No.
Thank you so much. I have so
Welcome.
many things to go through later. I have in my notes. Thank you.
Okay, it's a super difficult subject, so probably what I will say will sound stupid, but you mentioned in Varna this like different deposits, or you had information about, I don't know, different hierarchical groups represented in the pottery. In another case, you say, oh, we have this elementary deposit in CC, which is an outlier, but it's a different assemblage. So how do you take into account the nature of the context? Is it a variable, or you are just focusing on where's time?
It is.
And this, how does it get into the picture? And how do you trust the archaeologist? Because, okay, people might define things differently or interpret things differently. So are you able to cope with these variations?
Yeah. Of course, yes. Functional aspects, in fact, with the character of the deposits, because then you're talking about functional aspects and parameters. They should be taken into consideration, and if you want to include them, you should form a table that emphasizes the types that have a specific functional aspects, because there are many gaps in the function of the types. So you need to form a table according to that. The functional, of course, yes, they should be taken into consideration. Though, for example, the work of Charles Sturges, who considers tableware, and he looks at tableware from a functional aspects, he pays a lot of attention to that. Here, the analysis that we did for CICI, for the Neopalatial deposits, the number one thing that we wanted to find was a chronological correlations, and whether we are like what you see in the Philacopy. That was the initial thing that I wanted to do, to take some things for granted and see where the deposits of the Neopalatial period stand in connection to each other. But the pottery was very repetitive, and that wasn't very successful.
Perhaps, if I may, could we have another slide? See the slide again of one of the graphs where I think it was somewhere in the middle, where you were plotting also the context, where 8 pottery types, I think the graph was saying, in 8 contexts.
Excuse me, I forgot. Which one?
No, there was one before.
Before?
After, I think it's the one with the
blue circle.
With the blue circle. Yes.
Wait, excuse me, because I didn't answer also to the other question of Maud. About the different interpretation of the archaeologists, of the people who have worked. That is a problem, because I need to look at the data from my own perspective and create possibly a different table. Because I need, for example, the example of Tina with the ogival cup will be a problem. I wouldn't say that ogival cup. No, I cannot combine the data from different archaeologists. I need to rethink of them and change some of the terminology according.
But then, because you show graphs and so on, and then I'm thinking, aren't you trusting the data? To what extent you are doing something that, okay, nothing is ever completely neutral, but you have these questions of shapes, you have this interpretation of the context. So I'm wondering if you orient everything in the way you want, how objective or neutral you are with something which is supposed to kind of come out, not naturally, because this doesn't look natural, but quite straightforwardly and like
Nah, I try to be loyal to my terminology, let's say it like that. And I'm trying to follow the terminology that I've been using and be loyal to that and enter a lot of data through my own eyes and my own terms. The more data, the better.
But just to follow up on that, so in an ideal world, you would have sifted through yourself all the material yourself and have revised the material yourself in an ideal hypothetical world, which we all know never really exists. So you can follow your typology, your definition of whatever a hash-shaped vessel is, and then you can follow it and you can define it and you can plot it as you see fit. But otherwise, you are then relying to a certain extent always on the definitions, on the typology, on the definition or the descriptions of archaeological context by other ceramic specialists, archaeologists, whatever.
And I can ask them also. You always can collaborate and ask people.
Well,
But this is why I also I analyze the data that I have seen.
exactly, which is
It would be difficult for me to do. Otherwise, there would be manipulation. If I, for example, I took a publication and started changing the types, and that would be manipulation.
Yeah.
I will be held responsible for that.
Right.
Eventually.
And you'll probably still be working on it right now because it's extremely time intensive.
Yeah.
So my point was, it's an extreme luxury that you are there. You can always accompany archaeologists in these certain projects that you were discussing. But coming back to context, because I was also interested in the plotting or associating.
The context, that one, the different context.
So you have 28 types in total, 36,000 shirts. And what exactly are the contexts? Are these defined contexts of the shirts?
The contexts are varied. It is in the article. They are primary, they are fields, which is a problem. They are primary, they are fields, but in the interpretation, when we interpreted the data, I took it into consideration, the different, and I try to understand why this type is there. Because it is, for example, it was the cooking area, so you have more cooking pots. So I analyzed that afterwards, and it is in the paper. I took it into consideration, but the ideal would be to have the same context, to have all fields if you are interested in the fields. Like they did in Troy, they took it into consideration also Blegen's heaps full of fields.
Any further questions, comments?
Thank you, Iro, for this interesting lecture. I think you are brave that you are doing all this analysis. First of all, a small question. How many materials, how many pots you have to have in order to perform this kind of analysis? What is representative? How much is representative? Because you said for CC it was this 1,000, but you had to limit all these sets. So how many is representative? It depends from your question, or it's very clear in the methodology of correspondence analysis.
If it is more than abundance, it is variation. This is the most important. To be varied. For example, if I did this analysis at Knossos with different Knossian deposits, because the pottery is very decorated, it would be very different, the diagram. More data are better, for sure. But the most important is that at CC, from the beginning, I would have chosen different things if I knew that I would have done correspondence analysis, from the beginning, when I was there cataloging pottery, because I didn't know that. That came after, the interest and all that. It's all work in progress at the end. This is what we all do. You never know from the beginning that you will end up doing correspondence analysis. And so I would have chosen other things in my catalog. More things, It's a matter of choice. So I'm reflecting now what I might have done, because more data are much better, better data not only more.
Further questions, comments?
Thank you. I just jumped because you made this comment about that in Troy they used the material from the heaps. So technically you might be able to do that even from material that is not stratified from old excavations.
Yeah.
Because I remember we discussed that about the Maya Palace and you said, oh, it's not possible because we don't have the context for the latest material, but it is technically possible.
Yeah, it is. No. It depends on the question. What you want to see. Variety, typological variety, for example, would be very evident. Chronology.
Yeah, but if it's not stratified, how is chronology gonna work? But then it's
With that-
not gonna make chronology, you're just gonna make typology.
It's relative.
Yeah.
You know,
Just that's why you said you take a different question.
But always it's interesting as an experiment.
There was, on that note, there was the Brown University excavation, Petra, where I was working with. They also they re-excavated the old excavation heaps, and then reanalyzed and collected all the pottery material, not only pottery material, all material that they missed, because they were not seeping back then, if I remember correctly. And of course, there is a great, you will never be able to reconstruct an exact stratigraphy, whatever. But it was an interesting mythology that with the old excavation diaries, they could then basically reconstruct a very rough, but still a negative stratigraphy, knowing that, okay, with the beginning of, let's say, 1st of July, they started with the excavations, they knew the excavation lasted for 6 weeks, they knew that, with this context they had, because they were counting the buckets. And so they could very roughly, kind of reconstruct it and more or less fit it. But they were sieving huge piles of excavation done for years, basically. And so you have to really be very sure about your methodology and what you really want to get out of this. Just for an added information, I guess will be a little bit.
If one has the resources, I guess.
But it nevertheless is very interesting. If there any further comments?
We could be here all night.
We could be here all night. But maybe as a closer, one last thing, because you closed your talk with admitting that these methodologies. I was seeing myself back into the statistical class 1 somewhere. It really challenges it. But this really is a serious question. Because something that we all deal with our various, spatial analytical methodologies, whatever. We all struggle with keeping true to our core disciplinary identities. And if you apply, because what you were saying, that it necessitates such a huge, technical knowledge. Because what you were presenting just today really requires very in-depth statistical knowledge, methodological skill, and experience mostly. So what would you try to advise, let's say, a young, aspiring researchers interested in these things? Because what you're also saying, how to counter-argue the argument that you're just basically evidencing the obvious. There's a good argument for it. I would say always trying to bring it back to the cultural historical question and to relate that to the subject matter that you're discussing. But what would your answer be?
I think it is something that is worth doing for sure if one wants to understand its data and understand the limitation of the data and understand actually the position of the deposit and what does it say, because you can exclude deposits from analysis also based on that. I think it is important to do that. Of course, one needs to have an interest in pottery or an interest in stone tools, for example, a specific interest in about an artifact that we found in quantities. Otherwise, it would be difficult. And of course, have the help of somebody, for sure, have lessons on statistics for this type of analysis. This is what was my problem from the beginning, that I wanted to find a mathematician, and I'm still in search of a mathematician with several universities to understand and because I want to see, I want somebody to be really, into that, to be obsessed. Yes, if we do that, if we take that out, if we do that, things like that.
The promise of interdisciplinary research.
Yeah, yes, right.
In any case, if there are no further last words, thank you once more for this very
Thank you also for inviting me.
And before we go, may I also advertise for our next upcoming Atlas speaker. Tim will be talking to us, introducing us to the demographical study of Athens and Piraeus based on a mapping project of forced entry of human race data. So we're very excited about that. On April the 28th, we'll be seeing each other, at least in this context, in approximately 1 month. So thank you again for coming, and more than happy to invite you all back in a month.
Yeah.
Thanks.